I've been on a lot of dives where almost every dive we discover a new species. The most amazing thing I've ever seen is an eruption of an underwater volcano with lava tubes streaming downslope at a mile deep, and just fiery lava pouring out. I mean,
Wow.
there's things that you just never even imagined that you would see with these wonderful remotely operated vehicles, and just the camaraderie.
Wait, you were on that cruise? There's only been like 1 or 2 times people have ever seen a volcano erupting underwater, right?
Yeah. Yes.
That's so
I've
cool.
seen one.
Tell us more.
I have that
there's-
footage.
There have been 2, one in, and I've been on both, one in the Mariana Arc at Northwest Rhoda. And that one was, you could see the rocks moving and maybe a little flash of red here and there, but the one in the Northeast Lao Basin, it was just spectacular. There were lava fountains, and
That footage is so iconic.
Wow.
it was, I'm sure you've probably seen the footage. It was all over the place. We got a nature paper out of it.
We were
It was
scooping up.
just incredible. My old boss, I've never seen him so excited in my life, Bob Embley. He never thought he'd ever see anything like it, and I doubt I'll ever see anything like it again. So, yeah, it's those serendipitous situations that make me still love going out to sea.
We were collecting the lava as it was coming out of the ground into a coffee can.
Yeah, yeah, and at the Northeast Lao Basin, we just took a titanium rod and dipped it into one of those pillow lavas and got a age 0 lava. It
Wow.
was, yeah, something else. We've been back there several times and not seen it erupted, but it erupts about every couple of years. So, but these methane plumes are really fascinating too, and we see several of the same organisms because they're chemosynthetic communities. You know, there's not sunlight that's producing, we used to think that you had to have light for life, but now we know that you can build this whole basis of these communities on the chemicals that are coming out of the seafloor. And there are several similar species. I mean, the fauna is just gorgeous, the tube worms and the clams. And we see that, especially at some of these deeper sea sites. So I'm interested to see what we'll see down here today.
We were at that erupting site there. The ROV has a Doppler that holds its position based on sound beams going to the bottom, and it looks at the relative position of those. We were sitting there holding position, and it suddenly started sliding back, and I thought there was something wrong with the Doppler. And it was because the ground was moving, and we were moving along with the ground.
Oh, wow. Whoa.
Were you on that Northwest Rhoda one, Bob?
Yeah.
Okay.
Yeah.
Okay.
Yeah, it was with Jason, right?
Right.
Yeah.
Right.
Yeah, it was heaving rocks up into the water column.
Right.
Whoa.
Yeah.
Like how high? How big of a rock?
They were lava
basketball
bombs.
size. Yeah.
Whoa.
You might be able to find that footage somewhere. I actually have it on my laptop.
We had a transducer so you could actually hear the noise,
Yeah,
What
we
did
had
it
a
sound like?
hydrophone on the bottom.
Yeah.
Wow, that sounds
2.
incredible.
That's the same expedition, Bob, where we went up to the northern part of the arc, and remember we went to that arc volcano and it had all the what was it? Shoot, we got stuck in sulfur.
Yep.
And the whole
That was
entire we sat down on the bottom.
that was
and
my watch.
the whole entire vehicle came up, and it was just laden with liquid sulfur. Well, it wasn't
So that also
liquid
happened
by then.
Yeah, that happened to Sebastian too. They did the same thing.
Yeah, so we spent the day chipping sulfur off of the ROV.
Yeah. It went right in the holes in the frame and like filled up the inside of the frame with molten sulfur. And
Oh no.
Yeah, the Mariana Arc is an amazing place, and it is in the U.S. EEZ. Although Nico, the volcano that happened on, that was in Japanese water. But every single volcano is different, you know, different chemistry. Arc volcanoes are, you know, you can have at one site it's carbon dioxide, at another it's sulfur, at another it's basalt. So yeah, it's pretty amazing, and it's a long, long stretch of volcanoes. Now, the Earth-Ocean Interactions group is hoping to go back to, now we're looking at the Mariana Back Arc, which is much deeper, not as explosive or dynamic. It's more like a spreading center, sort of like going to the Juan de Fuca Ridge offshore Oregon here. But some really interesting biology and vents, and we're kind of trying to compare the back arc biota to what we see on the arc volcanoes. And it's different. Even though they kind of look the same, they're totally different species.
ROV, I'm still not hearing from the cell cam. Can you power cycle that one more time?
Yeah, you got it.
It's not sitting on the workbench, is it?
No, it's not.
So Chris, why don't you tell them what you're going to do out here today?
So today, we're going to be mapping this site later this afternoon. Earlier I was talking about how we pointed the multi-beam sonar downward, so that's so we can better see the bottom and hopefully make a good map. We've been working on improving the nav system this year so far, so this will be a good chance to test it and hopefully get a good product.
We're looking forward to it because we can get a lot more, a very high resolution map when you have the sonar close to the seafloor. A lot more high resolution than we're going to get from the sea surface, which is 1,600 meters above us. So Chris will be about, how high, 20 meters above the
Something like that, yeah.
site?
We'll adjust the height depending on how the sonar returns look and how wide a beam we can get away with. But
yeah, that's the amazing thing about mapping the seafloor. You know, you can map it from a ship, and these water depths, we might be able to get 20-meter resolution. So that means that you can see something on the seafloor that's 20 meters by 20 meters, a 20-meter square. But then you can send out from the ship, you can send out autonomous vehicles, and they can get closer to the seafloor. And with those autonomous vehicles, we can get resolution of like 1 meter by 1 meter. So, and now 0.5 meter by 0.5 meter. And that's kind of I would imagine that's what we're looking at here, Chris, for resolution. It depends on how high above the seafloor he flies.
yeah, we should be, if all goes well, we should be able to get maybe 0.5 meter or even 25 centimeter resolution if we, yeah, depending on how low we can get and how
that kind of
go.
Bottom's in sight.
Oh my, here we are.
Found it.
We're jacking.
Okay, there it
Found
is.
it.
Touchdown.
Oh my gosh, it's a tsunami of mud.
Stick lock. That was my...
Roger.
You just...
All right. Well, here we are.
Here we are. So that took us about an hour.
That's out.
Okay. So you want to turn around and look at me?
Yep.
And I will get out of this. So that was not the setting for that.
Right.
That's
Okay, what today? You are facing
Sorry,
180.
what was that, Tim? Oh, yes.
Where's our target? Chris?
Sorry. 50 meters, 045.
Well, you just hold there, I'll come around.
Okay, roger.
So we're on the bottom. And we're going to head to a spot where 2 days ago we saw a beautiful bubble stream. And this morning when we passed over it, we did not see it.
Ooh.
So these bubble streamers are very nefarious. I mean, nebulous. They come and they go. We think that tides can influence and turn them on and off. And like we said before, I mean, even if you set the vehicle down next to them, sometimes they turn on and off. So we're just hoping that it's woken up again. Irregardless, the feature that we're going to be looking at is super interesting. So hoping for the best.
Yeah, as we set up on the seafloor here, the front row will work together to get vehicles in position, cameras calibrated. We'll take off. Our dive today is scheduled.
Megan, it's kind of hard to hear you.
Is it?
Yeah.
She's still here.
I'm
I'll
still,
turn
I'm
her
still
up.
in the studio multitasking.
Studio
Sorry.
2?
1.
Studio 1. I got you at 9 dB. You should.
Weird.
Thank you.
There's 12 dB.
Don't want to blow you all out. Can you
No,
hear
that's
me?
good. That's better.
Better now?
Yeah.
Cool.
Yeah, I thought it was just me.
Nope, just me.
Good.
You want to reset Doppler?
Yes.
So this is the deepest site that we've been to so far in this expedition. The first one was in about 350 meters of water, and yesterday at Astoria Canyon we were in about 850, so we've doubled that today. We're in about 1,600 meters of water. Obviously a lot of sediment on the seafloor.
You missed your opportunity to use the Norbit to look at the bottom.
Oh, I saw the bottom. I wanted to determine when I could first see the bottom, not when we were on it. Figured we could use the cameras for that.
Yeah, you should have been looking.
It's important to ground truth you 0.
Can we get a white balance when you get a chance?
Can you describe what the white balance is?
Sure, the white balance is a way that we electronically calibrate the dark part of the scenes and the color of the scenes so that any researcher who looks at our footage later knows that we have accurately captured what we're seeing. Of course, white balance is a function of distance from the camera, as light does not transmit through water well. All the wavelengths get absorbed at different rates. So it's really setting it for a fixed distance, but it's still a good starting point.
Lasers off.
Please. Doing gauges.
I'm gonna zoom in, Ed.
Coming in.
No.
Shoot.
Shocking.
Can you give me a slight bump to the right, or do you think it's going to be too far?
Oh, well, we're deeper. It probably worked
Yeah,
out.
there you go. There you go. That's good. All right, black balance, camera intentionally dark, starting now.
Bob, why does the depth matter on how much that camera moves?
The pan and tilt is hydraulic,
White balancing.
and you got to kind of adjust the needle valve to like make it work. It's a difficult problem. So on the surface, when you're sitting on deck and you're trying to tweak the thing, you got to make it so it's pretty snappy if you're going to, because as you go down, it gets slower and slower. So you kind of got to, it's
Pre-compensate for
yeah,
how it works at depth.
pre-compensate. Yeah,
And then at different depths, it responds differently. So
Yeah.
you might have it dialed in yesterday,
yeah.
but today we're at a different depth, and you can't
Yeah.
make an adjustment once it's down here.
And then if you're going from like the bottom of a slope and going up, you know, so it's really a judgment call, you know. And if you tweak it down so it's too low and you go to depth, it won't move at all.
Yeah.
And don't want that. So better for it to be like overly snappy than to tweak it down where it's really smooth, but might not work at all. Oop, put it away.
We're looking at the two gas type models in the front.
So Herc 2
Awesome.
will not have a hydraulic pan and tilt.
Electric?
Electric, yeah.
Stepper motors.
And the pilot will be able to delegate control of that over here to video.
Yeah, I don't know. There might be a battle going on there.
Well, if we do a pilot cam that you can fly by.
Yeah, but you only have so much space, right?
Yeah, well, then you end up with a D2,
A who to?
a different ROV.
Uh,
You can chase that size equation to its
Yeah.
terminus.
kind of one of the advantages of Herc is that it's small, but small being it's maneuverable and it's easy to fly and gets in places where a lot of other vehicles won't, but it limits how much stuff you can hang on it. Okay, where are we going?
Okay. Looks like we are going 110. And we're going to need a
110.
ship move. So once you get started, I'll get the ship
Okay.
rolling.
All right, Kai, coming around to 110.
So we'll be coming down a little bit. We're hoping to see this bubble plume. It'll be kind of at the base of this donut-shaped structure on the southeast corner. See. So this feature is about
Range nav, 40 meters, 095.
20 meters deep in the center. It's about 400 meters across by 300 meters.
A rat tail?
That's a rat tail.
Yeah, good morning, George. 40 meters, 095.
Wait, Susan, did you say it's 400 meters by 300 meters across?
It's, yeah,
It's a massive donut.
it's a
We're
big donut.
we're really not talking about the same kind of pockmark feature
Right.
from yesterday.
This is bigger than a voodoo donut. Yes.
Portland reference.
And it's about 30 meters, well, 20 meters from the top of the rim to the bottom.
Okay. 3 football fields by 4 football fields. For 1 international football field.
Yeah. Yeah.
ROV Hercules is rated to dive to 4,000 meters, 13,000 feet, 40 football fields. What are the instruments on it that limit that depth rating?
I don't think anything.
Right
that
now
we
the
have
bubble
on.
cam is one of them. It's rated to 3,000 meters. We put a shallow
Well,
one on.
I think the big deal is the syntactic foam.
What's it rated to?
4,000 meters.
Well, that's it.
Yeah.
And
And you
they-
can order different foam.
Yeah.
Yeah.
The deeper rated foam costs more money
And the
and it's
syntax,
and it's
tactic.
heavier. So you get less buoyancy per cubic foot. So that goes along with the size of the vehicle issue, right? So you get heavier foam, you need more of it then. And if you have more of it, then you need to support it, and you got a bigger frame, on and on. Bigger frame means
Bigger
weighs
thrusters.
more.
Yeah.
Means you need a bigger crane,
Yeah.
bigger A-frame.
Well, bigger frame weighs more, you need more foam. So, yeah.
And the foam is used for buoyancy, right? To make sure that you
Yep.
can get the vehicle back off the bottom.
Yeah. Otherwise, it would be a dead weight sitting on the bottom.
But we operate just slightly positively buoyant most of the
Yeah.
time.
So Herc weighs 5,000 pounds in air, but it's actually buoyant in water. It floats.
Yeah, so at the 4,000 meter depth rating, we can get to 50% of the world's ocean. We have another vehicle, Little Hercules, that's an observation platform camera vehicle that's rated to go to 6,000 meters. And being able to dive to 6,000 meters can get you to 90% of the global ocean. So our goal in the future, we'd love to design what we're calling Hercules 2 right now. They come up with a different name. That would be the same scale of vehicle with the same kind of capabilities as Hercules has, but
An
rated
octopus.
for 6,000 meters.
This is the second one I've seen. Did you catch that, Taylor Ann?
Little
Second.
purple octopus sitting
They're
on the
little
seafloor.
tiny purple octopi.
Second one
Octopus.
we've seen.
I forget which root that is, Latin or Greek.
So are we using Norbit, or you're just checking it out? Can we turn it off?
Yeah, you can shut it off if you want.
Constant ground fault. I don't like it.
Got it. Orbit secure.
Raj.
So we'll be seeing some different fish down here than we've seen on previous dives. In front of us you see another rat tail, which are prevalent in the deep sea. They're also called grenadier, if you see them in the grocery store. They've become quite a big commercial fishery. But we, in the deep sea community, have always referred to them as rat tails. I'm not sure I'd eat one.
You don't find them named that in the grocery store.
No, they're grenadiers.
It's amazing that that's a fishery target. Not a lot of fish.
So we're seeing some shell debris. It's looking positive. Like I said, this should be kind of at the
Sea
base.
pigs.
Sea pig?
Yay.
Yeah, 2 of them off to the right.
What's a
Bridge
sea pig
nav.
in?
I'm not sure I know
25
what a sea
meters.
pig is.
Oh, it's not like the Marv
100.
Lily sea pigs. They're they're a type of holothurian. They have short, stubby legs, like 6 to 8 of them. I'm the worst guy to be describing biology.
You're doing
Hop
great.
in there.
Yeah, you said exactly what I was going to
Just
say. A
realize-
holothurian, not too different from like a sea cucumber. I mean, they are different, but they're both holothurians. Yeah, they're pretty fun to look at. Where did they go?
They're behind us to the right.
I think there's one right there.
There'll be
Zoom
one
in.
somewhere else.
Zoom in.
Coming
Yeah,
in.
sure.
I don't see what you're seeing.
No.
Okay, so we've seen
They're larger than that. There'll be more. There's
bivalves.
one, there's many.
Oh, and we're seeing a little bit of bacterial mat coming up, so
Mhm.
that's a positive sign that the sleep site is active. That's good. We can do some sampling of the mat eventually. But we'd like to go over and find
There's some.
an active bubble stream.
Yeah,
so we
there's
can
one.
Want to zoom in, Ed?
Yeah.
There's
get
2
some
of 'em.
gas samples.
Let's get this guy. This one's in kind of a weird posture.
A lot of holes.
That
Oh, that
Is
does
a
look like a
sea-
little pig.
Yeah.
For a holothurian, it's pretty cute.
And they have sort of a pad style, a sticky pad style mouth parts there. So they'll press them down in the detritus and then bring them back up to their mouth like tube foot, similar to the way starfish can pass things to their mouth. And then they'll kind of like, I don't know, I imagine kind of like putting your palm down on your dinner plate and then like bringing your hand up to your mouth and then like putting your other palm down and like just feeding in that manner.
Yeah, you can see some of their poop too
Mhm.
behind them.
Little trail, little recycler,
They're really cute.
leaving behind clean sand, eating all the bits in between.
This is why I'm a geologist.
coming out.
This is positive. We're seeing some shell,
Clams.
clamshell fragments, some bacterial mat. Hopefully we'll see a lot more of that as we approach waypoint 1, where we're hoping to find an
How
active
far we gotta
bubble
go?
stream.
It's only a few more meters, 25 meters.
Is there a marker there?
No, we've never been here, Bob.
Oh,
Brand new. This is exploration. In fact, most of the sites we're going to visit, we've never been to. We'll have a couple of repeats if we are lucky enough to get all our dives in, weather permitting. Okay, so here's some the white patches you're seeing are bacterial mat that are feeding off the microbes, the thanatropes, and
we're getting bubbles coming up. as we
Where?
go along, I think.
where?
I could be imagining things, but
Oh, please.
kind of looks like in that view.
Oh, wow. Yeah.
Can you see them in art? Could zoom in with Argus. Maybe you can see them.
Go ahead.
Coming in.
Could
Holding.
be imagining things.
Oh, no. Yeah, we're close.
Doesn't that, those look like bubbles in the.
They do, yeah.
They're
Oh, yeah.
definitely bubbles.
There are bubbles. Where is
Zooming back
the
out on that.
orifice?
Roger.
Looks like you passed.
Where are they coming
Yeah, as
from?
we stir up the bottom, I think we're kind of
Oh,
kicking up
don't
some
do that.
bubbles here and there.
So can you put down a target for bubbles, Chris?
There's no stream. I think just
Right.
us going over it is stirring them up, you know?
But
See
that
them?
is-
See them in that?
In the
see 'em in
Niskins.
that
Yeah.
Yeah.
Niskin view?
let's put a target down anyway.
Yep.
Thank you. Because like I said this morning, we didn't see anything in the multi-beam data, so.
Yeah, there was no stream. It was just as
There's
I was stirring up the bottom, it was kicking up
some
random
live
bubbles.
snails, it looks like.
So we're going to have to excavate for bubbles.
Make our own.
Okay, so now we're getting kind of out of that bacterial mat area. Still seeing shell fragments.
We there yet?
Just about. 5 meters. Straight ahead.
Well, that is not looking too promising, but
Yeah. More stuff floating up.
I don't see anything around here. This is it, right?
Ridge nav, 5 meters, 100.
Well, there's some matting.
let's go over and look at that.
What are we looking at?
The mat to starboard. Looks like a
Oh, Matt.
bit larger area, and now it looks like we're sitting pretty much right on top of the waypoint, so.
Yep.
Let's kind of look around here.
So is there active bubbling here, or just?
Well, there was 2 days ago, but this morning we didn't see anything. 2 days ago, it looked like it was a really strong bubble stream, so.
Wonder if we're more likely to see them at high tide.
Yeah.
In what?
At high tide?
Low tide.
Low tide's more likely?
Yeah. High tide is, you know, you got more water piled on top of them. So they think that high tides can shut them off. And I'm not sure what the tidal cycle is right now.
There might be bubbles near the starboard bio box.
Starboard?
You see them?
Do you see?
We might be fooling ourselves though by when I thrust it, like sucks things up.
Maybe, but it doesn't look like
Well, they're going back
Dust.
down,
stuff.
though.
It's, you know, reflective like bubbles.
Well, do we want to try coming up and looking
Roger.
sonar-y?
The Sea King is set to 10-meter range.
Okay, we're going to search around this area with white bacterial mat, some shell fragments, looks like clams, which are common species at these seep sites. Okay, we should.
Better with a down light off, or no, not really.
Maybe down off and porch on.
Nah, porch is way in the back, so it's gonna It's going to make the shininess of the bottles even worse.
Okay.
Maybe not. That was
So right
a
now
Kylie,
we're
I told you so.
I didn't say it. I didn't say it.
so right now we're to the south of the waypoint, I believe.
Which side on this is Argus?
I think Argus is on the right, is what I think.
Because there's something.
Let's just do it. I'm going to do it. That's Herc. Argus is on the right.
Argus
Wait,
is on the left?
Argus is on the right.
Argus on the right. I just turned off the sonar, and that was Herc's sonar.
Okay.
Wait, but the one on the left stopped moving, so I thought
Yeah.
that would be the one you turned off.
Yeah.
So Argus is on the right.
That's exactly what I said.
You said Argus is on the left.
I didn't.
Okay.
I didn't say that.
Oh my gosh.
I don't know. There's witnesses.
Who's on first?
It's all recorded. We can look at the footage later. But I keep seeing something right here, see?
Yeah.
You find it for us, Chris. You've been so successful. Looking in that downward looking camera, I mean, it looks quite positive. We're seeing a lot of these little patches of
Yeah.
bacterial mat.
Yeah,
And
and some
sometimes we see
conical-shelled, organisms.
sometimes we see these
That's the mouse.
bubble streams just coming out of a little hole in the seafloor surrounded by bacterial mat.
Hold there for a second, Bob.
Oh,
I don't know. We're still kind of low, so it maybe it's just
Yeah.
something else. But I don't know. It's still,
are you reversing over it?
yeah.
Quite close to,
Oh, that's pretty strong.
Yeah.
of course these things can be off.
We're looking into the slope more that direction.
Yeah, so that might just be
Stuff.
stuff on the bottom. Yeah, because we're not seeing anything in Argus.
Right. I mean, our divisions are a little bit.
It's probably, yeah, you can see kind of the slope underneath it, I guess.
right.
It's probably just,
Right, because yeah, we're facing opposite
Oh.
directions.
We can go look.
Okay.
How far is that?
Well, maybe we should pull up and
it's
look around. Bob?
15 meters
Use an orbit.
straight up.
Yeah, I think we want to kind of just go look at this thing.
Because we're sitting right on the target.
I'm heading off this way.
What are you doing?
You're just seeing something on the sonar
Oh, you are?
that's either just stuff on the slope or, yeah.
That?
I think
Oh,
I'm
okay.
guessing stuff on the slope.
it's just stuff on the slope. Yeah.
Stuff on the slope.
I will say that the shell hash here is a lot larger. Like it
Yeah.
looks like the organisms are
Yeah, I think that's all we're
Much
picking up
bigger.
is the,
Yeah.
is the shell hash reflections.
Yes, not stuff on the slope, it's shell hash. Okay. I think, yeah, maybe we should try to use that fancy smancy.
All right, so you want
Oops.
to come up?
Yeah, why don't you come up
So
and
that's down facing. So Kylie, you want to turn on the orbit?
Sure. Orbit's on.
We're going to come up. So
okay, we're gonna come up off the bottom and look around with the sonar and see if we pick up some reflection of the bubbles in that sonar. Kylie, you want to explain this sonar that we're using?
Chris?
Which sonar are we explaining?
Which one are we using?
Oh, for this one orbit.
Which one aren't we using?
They're all on.
They're all on.
Swath. We'll go all the way wide.
Give it just more range on that.
Sure.
Gizmachi.
20?
Yeah. 20. Yeah, I guess so.
30?
Let's try 20 first.
Interesting.
That's noise. That's interference from other sonars. That's kind of a problem. We have so many sonars that they step on each other, sort of.
Is it dependent on the frequency?
Yeah.
Oh yeah, we can.
So the hard white line is the bottom, right? Like it's like the horizon or whatever?
Yep. So maybe try to just spin around very slowly.
Okay. Let's see which way we need to go. We need to go. I need to go clockwise. You need to go counterclockwise.
I'll go counterclockwise. Yeah.
Yeah, you can take your 6-8 route out.
Okay.
No, that was probably nothing.
Yeah, it stopped rotating.
What sonar are we using right now?
All of them.
Well, Chris is looking at the Norbit, and
Orbit.
I'm looking at the Sea King. And
Orbit, say hello to Sat 3.
It's like an ultrasound screen.
All right, I've got that Norbit on Sat 3. Chris, let me know if you turn that off or stop using it, please.
And that should be, that's CAMAC 2 you have it on?
Yes.
Okay, because there's a computer called Norbit, which we're not actually using for Norbit.
No, why would we do that?
No.
Seen anything yet?
Okay, I'm going to keep rotating.
Raj.
As the team does those sector scans, hello to the Ocean Science Exploration Camp who are tuning in with us. Thanks for being here and rolling along. Let us know your questions. We're happy to bring them into the conversation. What we're doing right now is scanning in all directions with the sonars, looking for those bubble plumes rising from the seafloor. And we'll go investigate them with the cameras.
What was the name of that camp, Megan? That sounds like a great camp. Ocean Science something?